This video has been brought to you by Wix, and we'll show you how they helped us make a new periodic table later in the episode.
Everyone knows that Mendeleev invented the periodic table, but did he really invent it? We're here to find out. We're here in St. Catherine's College, Cambridge, where the well-known chemist Peter Wathers has assembled a unique collection of early books about the periodic table, including, I believe, some real treasures from Mendeleev's output. Let's go in and see what he's got.
Well, I think most people would expect us to begin with Mendeleev's first periodic table. So this features in volume 1 of his textbook, The System of Chemistry here, and it was literally, this is just added in at the beginning. So this is the first published periodic table.
Wow.
Which is really rather nice. So how is your Russian then? You can read this okay, can you?
Система элементов. So it's based on their atomic weight and their chemical properties.
So this is a system of the elements, chemical elements. So of course the immediately noticeable first thing is it's the wrong way round from our modern periodic table. Mendeleev has arranged his groups horizontally in this, which is fine. So for instance, we see lithium, sodium, potassium, rubidium, cesium. Now he's got this one wrong. He's got a few wrong.
Yeah. Has he got any elements that don't exist?
Yes, there is somewhere didymium. We say it doesn't exist, but of course was resolved. Exactly.
Explain to me, what's the book and why did he wait till the last minute for the best part?
He was writing a textbook of inorganic chemistry, and he'd already written volume 1, and this had actually already been printed. And it was as he was beginning to write further parts of this, he thought, well, where am I going to go next? Well, we won't say the periodic table because there wasn't one, but after discussing related elements, he thought, well, which set of elements shall I do next? So he wanted to come up with a system, and this is his system. But the books were already printed, this first volume, and so a few leaves here were just sent in to literally be stuck in, to be pasted in to the printed books, which is remarkable. This is rather a nice copy, actually, because it was, we think the first owner was a lady, perhaps one of his students.
Somebody's made notes.
Yes, I'm not quite sure what these are yet. I'm going to have to work through that. It is quite a rare book, or at least we don't know how many copies there are outside of Russia. We think this is the only copy in the UK. So I mentioned that the groups in this are arranged horizontally, but in the second volume, which came out 2 years later, he's changed this. He's rearranged his periodic table to be far more recognizable to our eyes. Now this one is rather tricky and fragile. It's so this is in the beginning of volume 2 of his book. So now you see we have hydrogen, lithium, sodium, potassium, rubidium, cesium going vertically down. So this looks much more like our modern periodic table.
And what is this extra bit here?
Again, he developed lots of different arrangements, actually. And so this is also quite good. I mean, it looks like a periodic table. So some of group 2 appear here and some over here. So magnesium is over here as opposed to in the group here. Similarly with sodium and so on. He had group 1A and 1B with the, and there's some sense to this, of course, as you know. I think the fact that this is now a rather more extensive fold-out chart just shows the importance that he attached to this, to his system. And obviously this is what he's absolutely famous for now.
What he's written here is the natural system of the elements. And he's put his name after it. So, I mean, he's really gluing his name to the periodic table straight away.
He really did this, actually. So this is, I think, one of the reasons why Mendeleev is often cited as the discoverer of the periodic table. He really promoted this. He says it was his discovery, the system, the law, the periodic law. But there were other people, as we shall see. So this was his first textbook. And I say it came out in 2. It's usually published in 2 volumes, although it came out perhaps in 4. And this second volume was 2 years after the very first table that we saw. But actually he did publish a more extensive journal article where he really describes the periodic system. Now this apparently was only printed in 80 copies. So now we really are quite lucky to have one of these here. So this is the very first volume of the Russian Chemical Society, the Journal of the Russian Chemical Society. So this then is Mendeleev's real first announcement of his periodic table and the system. So this is the discovery of the periodic law, as he called it. And obviously he realized that there was something quite fundamental behind this. And perhaps the reason why his table and system caught on more than others is because he was also predicting properties of the elements, very detailed predictions. And that's perhaps some of the other discoverers didn't go into the same level of detail that he did. But we see exactly the same table that we saw in the textbook, yes. Now, I think what's really fun is, so we see this amazing discovery, this amazing announcement, to see the first report of this in English. Yes. Okay, and this was from the same year, and it's in the Chemical News. Now, this was a publication by William Crookes. He was the editor, the discoverer of thallium, of course. And it was said that he just reported anything, absolutely everything that was ever sort of anything chemical appeared in here. And so in here we have this here is the very first announcement in English of Mendeleev's system.
Can you read it out?
Yes, it says atomic weights, Mendeleev. This paper contains a new plan of grouping the elements according to the numerical value of their atomic weights in the following manner. Now you have to listen carefully here. So lithium 7, beryllium 9.4, boron 11, carbon 12, nitrogen 14, oxygen, he's given the symbols here, so O16, then Fe 19, then Na23. So they even get the order wrong. There's a misprint where they put the symbol for iron instead of
fluorine,
which I think is wonderful, isn't it? But that's it. This tiny little paragraph here is the first announcement of the and it was completely overlooked really at the time. Nobody really took much notice of this. And this was because I think, well, people really took notice when the first elements were discovered that agreed with his predictions. So he says at the end here, the author points out that this grouping of the elements expresses the law according to which the elements can combine with oxygen. As you see, this publication then in the Chemical News was in December the 10th, 1869. So it's the same year, yes.
But it's took quite a long time from March to December.
Yes, but this is because they were picking up these entries in other foreign journals, as they say here, as they describe it. But what I think is particularly nice, where it says, the author points out that this grouping of the elements, well, they don't actually show any grouping in this, because they just give the first line of his table, which is ridiculous.
But it also shows that more senior chemists are notorious for not recognizing breakthroughs when they happen. And
Absolutely.
Things haven't changed.
So while we're on Mendeleev, I thought I'd show you this. This is rather nice. So this has been described as his master's thesis, this tiny little pamphlet here. There's evidence that he's thinking of atomic weights and organization of things in here. We see lots of nice formulae for different compounds and so on.
So it says here that it was chosen for the defense of the degree of Master of Chemistry.
In some bibliographies, you see this is described as his thesis, but it turns out that this is just the synopsis.
Yes.
And I'm delighted that we also have the whole thesis here, which is really rather nice. And we haven't found another copy of this recorded in any library to date. There must be copies in Russia, of course, but we haven't found any others yet. So I think he's looking for specific volumes. So these are essentially what we would now call molar volumes of compounds. And again, this is starting thinking about looking for trends and patterns here. Mendeleev went through 8 different editions of his textbook. And of course, he had to introduce a whole new group with the noble gases. These don't feature in the first. But I think this one is rather fun. So I think this is his last. It's not an edition of his textbook, but it does contain his last periodic table. Published in a remarkable journal. It's crazy. In a serialized form in this journal with all sorts of strange articles in. So this, as I say, this really is quite an odd thing to find this final periodic table in here. And so this was, I think, his last version of the periodic table. But he made a slight error here because he put the noble gases in as group 0, which makes perfect sense. It's the valency is 0. But this meant then he put helium just before lithium. And then this therefore suggested, with hydrogen above lithium, that there might be another element above helium and one more above hydrogen. So he has X and Y as 2 unknown elements. Now, one of these, it was thought, had been discovered in the sun. This was coronium, which it turns out to be a highly oxidized ion of iron. But the other one he thought was undiscovered, and he proposed the name Newtonium, which I think is rather nice, which brings us back to Cambridge.
Well, you could argue that the neutron should go there, and I've got at least one periodic table that has the neutron on it. So you could pop in the neutron there if you wanted.
You could. This is the 4th edition of his textbook where the first periodic table appeared, but this is an amazing copy. This is actually a presentation copy from Mendeleev. This was presented to the Scottish chemist Alexander Crumb Brown, who was one of the people who developed organic structures.
Yes, I've heard of him. Did he read Russian or?
Well, yes, that's a good question, actually. I don't know. Mendeleev visited Crumb Brown in Edinburgh.
Yes, it says Edinburgh there.
Yep, to receive an honorary degree. So this was at that time. So it's dated there, 1884, which is really rather lovely, isn't it?
How much is that worth?
I have no idea how much this would be worth now, but it's really quite fun. So this is the version of the periodic table that appears in here. Interestingly enough, this one page appeared at auction last week in Christie's. It was also signed by Mendeleev, like our book is, and it sold for over £20,000.
£20,000 for one page. Yes. So how many pages have you got here?
I don't think we can extrapolate like that, but I think this complete volume would be quite pricey. Yeah. Now, I want to go back to Mendeleev's first published periodic table. So this was the one from 1869. And the reason I want to do this is because I want you to see another one from an English chemist called William Odling. So this is 5 years earlier. So this is from 1864. So for instance, we have sodium, potassium, rubidium, cesium. Now he's put lithium, wrong symbol, up here. And of course, Mendeleev gets his, includes lithium here. But for group 2, we have glucinium, so the old name for beryllium, and lead here. And then we have magnesium, calcium, strontium, and barium. And group 2, we have beryllium, magnesium. So they're separate from the other members, calcium, strontium, barium. And again, Mendeleev puts lead in the same group, understandably. But when we go to compare some of the other groups in the main group, they get even closer, the similarities. So group 3 or 13 of the periodic table is a tricky one because, of course, they only had a couple of elements. So Mendeleev only knew of boron and aluminium. So we have boron, aluminium, unknown, and uranium and gold from Mendeleev's. And here we have boron, aluminium, a space, again, where gallium will come, and then again, uranium there. So they're really very, very similar, these tables. When we go to group 15 or 5, nitrogen, phosphorus, arsenic, antimony, bismuth, completely right in Odling's table, and completely right in Mendeleev's, nitrogen, phosphorus, arsenic, antimony, bismuth.
So where did he publish this?
So this is in a journal it's not a chemical journal, so this is the Journal of Science. So there are many different articles in this from related subjects. But he didn't really push this in the same way that Mendeleev did later. And he didn't really produce such accurate predictions for the properties of the missing elements. And that was the thing that really caught people's attention from Mendeleev's version.
And what did he call his article?
I think it's just an arrangement. So the title of his article is On the Proportional Numbers
of the Elements. But so he was quite an eminent scientist. He was a fellow of the Royal Society.
Yes.
It shows that you not only got to discover something or propose something, but other people have to find out about it. And if you publish it somewhere where nobody else sees it, then you might as well not publish it at all. So what's his name?
William Odling.
Well, you must say that Odling does not have the sound of Mendeleev's name, does it?
It's interesting that the groups also are going horizontally as well, like Mendeleev's first version.
Professor Polyakov, did you know about this before today? Is this
Well, I knew that there were some previous ones, but I'd never realized how similar it was. Don't you think that perhaps the reason they go horizontally because it's easier from the point of view of putting it in a book? You don't have to change the landscape format of the page.
Well, but then again, of course, I mean, the arrangement by mass is now going vertically downwards. So something's got to go down and something's got to go across.
If this was 5 years before, isn't it conceivable that Mendeleev saw this and it inspired his arrangement?
It is possible that Mendeleev may have seen this. It was, I think this was translated into Russian, not by him, but he says he wasn't aware of it.
Oh, he was asked about it, was he?
Yeah. But and this is not the only British chemist who developed the periodic table. Perhaps more famous is Newland's and his law of octaves. Now, eventually, Newlands really wanted to try to establish some claim to the periodic table. So he published this lovely little book where all of his collected journal articles were assembled together. Now, I have one of the original ones to show you in a moment, but this is a nice copy. So this is to Grenville Williams. He was one of the people that worked with Crookes in the discovery of thallium. So Crookes mentions him at the end of his paper, which is rather nice. So this shows his attempts at coming up with a periodic table. But these were initially published in the Chemical News. And so this is the first version of Newlands' announcement when he's beginning to look for relationships between the atomic masses. So this is in here on relations among the equivalents. In this version, he's looking for relationships between what we would now call atomic weights. Some of them are out by a factor of 2, and this is because they just were not known at the time. So many of these look wrong to us. So they are halved. So magnesium 12, oxygen 8, and so on. But some of them are correct. So lithium 7, fluorine 19.
Yes, and nitrogen 14.
So his first table, though, we see comes a little bit later. Here are some of his early tables. So again, this one is going across. So we have hydrogen, fluorine, chlorine, then bromine and iodine. So this is very similar to Mendeleev's version. This particular one is from 1865.
Did Mendeleev, was he also asked about Newland's work?
Mendeleev just said that his version was very different and that he really discovered the periodic law. So interestingly, most of the copies of this that I've seen are signed by the author. So actually one of those books where it's the very rare copy that isn't signed by the author. But this was because he was trying to promote his system to show that he had a sense of priority for the discovery.
So what is this table here? Perhaps I'll let you take it out in case I damage it.
So the elements in order of atomic weight, horizontal arrangement. So again, this is fairly similar to Mendeleev's. What Newlands noticed, of course, is that when the elements are arranged, when we come to the, by order of their atomic weights, as they were known at the time, when you come to the 8th element in the order, we have something with similar properties. Yes. And so this was his discovery, that, and why he called it the law of octaves, because of course it's similar with the notes on a piano. Yes. When you go 8 up, you get to a similar related note. But of course, also missing from this, because they were not discovered at the time, were the noble gases. Yes. And this means when you include those, it will be every 9th element. So then it would be the law of nonaves.
This is really very interesting.
So these are all quite fun, but actually what I'm going to show you now is regarded as perhaps the very first periodic table. And do you know who this is by?
No.
No, this is a French mineralogist called Alexandre Émile Beguier de Chancourtois. And that one definitely doesn't roll off the tongue. No. Now, before I show you his table, I shall show you we're fortunate enough to have this. This is a collection of his offprints, and this was given to one of his colleagues, and he included a photograph. So this is actually a photograph of Beguier de Chancourtois. And signed by him, which is rather nice. His arrangement, this, nobody knows of him, and it really didn't catch on, but this was 7 years before Mendeleev's version. The reason this did not catch on is because, well, for starters, he was a mineralogist, so he wasn't really being read by the chemists of the day. But the main reason is he published this in a journal with no diagram. So there was no table in the original journal version. However, he also had some offprints made, as he did in those days. So these were separate printings of the article, and with this he did have an illustration made. And this one I need to have some space here, so let's open this out. And this is the reason that nobody knew of it, because it couldn't be included in the publication because this is so large. So you can see why the publishers were reluctant to include this in the journal article. So this is printed on card. It's got red, black, and green colours in it, and it's about 5 foot long. But now, what we're looking at here. So what do we need for a periodic table? We need all of the then known elements to be arranged in order of their, well, in this case, atomic weights. because of course nobody had any idea of atomic number at this time. And so these are all the elements arranged according to their atomic weight, and we need to look for the repeating patterns. And this is, the way he's done this is, these are arranged, this should be a cylinder. So at the top here we have a view from above of a cylinder. Again, we're going round 16 units around here. And so this would be 16 atomic weight units, atomic mass units, and then we come to an element with a similar property. So this is going to be arranged it'll form a helix. So this is being wound round the cylinder here. So for instance, we have, here is lithium, and then he found that elements with similar properties are aligned in the vertical column. So we have lithium here, sodium, potassium, and then if we go a bit further down, rubidium.
That is amazing. I've not heard of him. I've never seen anything like this, and it's extraordinary.
Well, this is really rather rare because this was only in the off-prints, not in the journal. So this is actually a signed copy again. So this was a presentation copy from Beguia here. And it's the survival of these charts. And he also changed these. So this, we think, is the very, very first version. So it says at the top here, the 7th of April, 1862. And there are slightly later versions where he modified this and so added a later date underneath where he just tweaked things. Because the real problem with this is well, what were the atomic weights of the elements? And this is where the problem came. And so actually we see on the table silicon, and silicon is also here. And it's on here a third time as well somewhere. So it's mentioned 3 times. And this is because he wasn't entirely sure what the mass, the atomic weight of silicon should be. Yeah. And this was because they understood that a certain mass of one element combined with a certain mass of another, but they didn't know what the formula for the product was. So we now know that when you combine silicon and oxygen, you have silicon dioxide. But they didn't know this. They knew that a certain mass is combined. And so depending on what the formula for silicon oxide is, silica, this would give rise to different masses. But he included them all in, which is great.
Do you think Mendeleev gets too much credit? Is history written wrong? Is history right? What does this make you feel? I don't know what to walk away thinking.
Well, I think you cannot alter history because sometimes 2 people or more discover something, but one of them has a more profound influence than the others. And so you can't, it's not enough to say, I discovered this first. You've got to look and see what influence you had on people that came after you. And sadly, sometimes it's not the first person that has the real influence, particularly because the second person may get a bit more momentum from knowing that somebody else has had a similar idea. So they're, first of all, pushing their idea harder, but they also have a bit more confidence in their idea.
I think it's no coincidence that actually 6 different scientists from around the world all independently came up with their versions of what we would now call the periodic table, all in the 1860s. And perhaps it's not surprising that one of them is going to be much more famous than the others. And I think deservedly so. I mean, Mendeleev did push things slightly further with his very accurate predictions of missing elements. And that's really what caught people's attention.
Okay, so I want to show you another periodic table. This is one we've put online. It's at periodicvideos.net, and we've built it using Wix, which is the sponsor of today's episode. Wix is a powerful, elegant tool that can help people at all levels, even me, make amazing websites. Whether it's business or a personal site, or maybe just something in between, get on Wix, get creating. It's free, highly customizable, as you can see here as I tweak our site. You can start with the template and then just take it in whatever direction you want. It's drag and drop, really intuitive, and there are loads of options. You can just change everything, get it just how you want it. If you do want to check them out, go to the URL wix.com/go/periodic videos. It's on the screen. That'll let them know you came from here, and that helps us as well. Hey, and once you've got your own site up and running, why not drop us an email so we can see what you did? That address again, wix.com/go/periodic videos. There's also a link in the description.
Spit. And saliva is actually used in conservation all the time. It's a really gentle cleaning agent. It's 99% water, 1% enzymes, and it's the enzymes that break down the dirt. So,
wow, you weren't joking.
under the tongue.
Is this like a known technique?
Yeah. Let's do a little section here.
This is kind of gross.